Hello, my name is Joy, and this is my presentation for the mock interview at Optiver as an engineering FPGA engineering intern for summer 2025. All the questions that I may be asked are presented over here. I have listed them, and I will be addressing them one by one or one by one chronologically. Um, so let's get started. So a little bit about myself. Everybody calls me Joy. I am a junior at Texas Tech University studying with computer engineering. I've got special skills in multiple programming languages such as Python, C, C++, Java, and most importantly, Verilog, because Verilog is used in FPGA development. Uh, I also have experience. Uh, I also have experience with multiple working on projects with Verilog, my most significant one being an autonomous rover with navigation systems um, on them, and I had to use the Basis 3 FPGA board. So why would I want to work at Optiver? Because I feel like Optiver has a focus on cutting edge FPGA technology, and I'm excited by that. I feel like I could contribute my FPGA skills to their latency critical applications. And of course, because I'm always eager to learn, I have a hunger to learn and get more experience from others. I feel like communicating with their senior developers and traders will help me understand the FPGA world a bit better. Now, can I describe a project where I had to solve a complex problem? I'm going to start by referring to my FPGA project, as I mentioned before. That is because I feel like that has been one of the toughest things I've had to work on. We had 3 months of time to finish the project, and in that 3 months, we had to figure out how the basis board works, get accustomed to the Vivado IDE, and additionally figure out solutions to find to for the navigations. Now, for navigations, our project descriptions were predetermined, and we had to find a ball that was emitting sound, and we had to go to the ball, drive our rovers to the ball, aim it towards a goalpost that was shooting IR at us. So that we can detect the IR, aim it at the goal, and then shoot at the goal. It was basically a penalty shootout rover. I had to figure out a solution for finding the sound, for localizing the sound so that we can navigate to the ball. And we had to do that using phase detection mics, where I had placed two microphones 6 centimeters apart so that we can figure out which way the sound's coming from. Additionally, we had to also figure out where the IR beacon is coming from, and we had to use frequency counting to figure out which way it's coming from. So I feel like that whole project was very, very crucial to my understanding of FPGAs, and I feel like all the problems that I had faced were something I had never seen before in my other projects, such as my Raspberry Pi project, which was much more straightforward than than the project I had worked with an FPGA. So, how do I handle tight feedback loops in a fast-paced environment? Well, I thrive on feedback in fast-paced environments, right? As I said, our projects usually have very short times. We have to figure out everything, and we have to make progress almost on a weekly basis. So, I feel like in a fast-paced environment, I am very quick, I'm very efficient. I try to manage my time to the utmost efficiency so that I learn and understand the stuff I'm working with. I'm very good with reading documentation, which helps me write better code and perform better as an engineer. I also have an experience as a tutor, and I tutor C programming with hardware applications in the AC department at Texas Tech. And I feel like being a tutor, I have had the opportunity to connect and work with other students and engineers to find solutions to problems. And I feel like all of these things help me help me make efficient solutions and very precise codes. What makes me passionate about clean code and well architected systems? Well, I think clean code and well-architected systems are necessary to any project, FPGA or not, because it helps you maintain the code. It helps you understand the logic. It improves readability. It helps you troubleshoot and debug, because it's important that we save memory, we save space, we make our code run faster, because the faster and the better it runs, the less resources we burn through. For example, when I was working with my Raspberry Pi project, I realized that if I used too many image processing functions, my Pi couldn't handle it. If I was using multiple files while running something in the background at the same time, my Pi would overheat, and latency and lag would show up. If I was displaying too many video files at the same time, my Pi would slow down. So it's very important that you reserve space and memory. So I feel like clean code helps you debug that better. I had to revisit and fix my logic. I had to reduce the number of loops I was using, for example. I feel like that is very important. And in the case of an FPGA, it is absolutely crucial. So it's absolutely crucial, right? And of course, Verilog is a very modular language, and writing modular code helps you optimize it much better. So I feel like that is all uh, I have had to offer. Thank you so much for considering my application, and I hope you have a good day. Thanks.